everyone, my name is Fallon Berry.
I'm Jenna Amison.
I'm Claire Shen.
And I'm Josh Lang.
And we are all biomedical engineering students at Northwestern University. Our product for your evaluation is the Chemotherapy Cooling Cap Sensing System.
Chemotherapy cold capping is currently the only FDA-approved treatment for chemotherapy-induced alopecia, which is the hair loss caused by chemotherapy drugs that attack proliferative cells, including cancer cells, as well as hair follicles. Cold capping works by constricting the vessels near the scalp, which reduces the drug's ability to reach these cells and prevents the loss of hair.
Current systems exist in two forms: automatic, which use electricity and coolant, and manual systems that rely on dry ice to cool caps that are switched out throughout the treatment. However, neither of these solutions allow for detection of scalp temperature. To address this, our team has developed a thermistor-based scalp temperature sensing device which measures temperature at multiple points across the scalp.
The main temperature sensing component is the thermistors, which features an easy-to-use mesh cap system that positions sensors directly on the scalp and holds their position as the outer cold cap cooling layers are placed on top of them. These thermistors then transmit data to the prototyping board, which is currently set up for 4 sensors but has capabilities of up to 12 at a time. Each circuit passes through a voltage divider and low-pass filter before data is sent into analog to digital converters, currently a part of the ESP32's dedicated pins. This output is then sent to a simple Python code for processing using the Steinhart-Hart equation and the thermistor's B-value to calculate a corresponding temperature.
Our device creates a real-time temperature readout and in the future a real-time temperature map, which can be used to inform clinicians and patients about problems reaching the appropriate scalp temperature. By understanding where the hotspots are, changes can be made during the treatment, allowing patients to still achieve appropriate scalp cooling temperatures, whereas without our device, patients wouldn't be able to know their scalp is reaching appropriate temperatures to allow for effective scalp cooling until after multiple treatment rounds have been completed. Now we'll look at a demonstration of our prototype.
Here is the mesh system at work. You can see that there are color-coordinated pins for each of the spots on the corresponding mesh. This is the mechanism that allows the pin to be easily placed into the hair. For the sake of this demonstration, we will be covering one of the pins with a foam and tape layer. We are now placing a bag of ice homogeneously across the entire mannequin's skull. With this demonstration, we are proving that an added layer of either hair or air affects the efficacy of the scalp cooling itself. Before any ice was applied, this is what the user interface of this prototype features. It shows all of the spots of the thermistors, too hot to be adequately cooled. As you can see, as time goes on, the temperature at the locations not covered by the foam decreased significantly more than the one covered by the foam.
Thank you so much for taking the time to look at our presentation. We hope that you enjoyed, and thank you for the consideration to the debut challenge.